Hey everyone, so today we're going to dig into a topic that is quite literally right under our feet, but it gets almost no attention in the big climate conversations. We are talking about soil. And you're about to see why it's this hidden giant in the whole global carbon story. So let me kick things off with a question for you. When you picture carbon being stored on land, where does your mind go? I bet you're thinking of huge, sprawling forests, right? All those trees, branches, and leaves. But what if I told you the biggest carbon warehouse wasn't even the stuff you can see? You got it. It's the soil. I mean, this is wild. The top layer of soil around the world holds more than 3 times the amount of carbon as all the planet's plants, trees, and forests combined. It's just staggering. So how in the world did it all get down there? Well, the story starts with the most fundamental cycle there is, the cycle of life and death. You see, when a plant or an animal dies, its carbon doesn't just disappear. It just begins a whole new journey. And that journey starts with something called dead organic matter. Now, that's just the official term for, all the stuff that was once alive. Fallen leaves, old roots, decaying critters. Think of it as the carbon delivery service for the soil. It's actually a really simple and beautiful process. Every single leaf that drops, every root that dies back, carries all the carbon it stored during its life right down into the soil. But what happens to it once it's there? Okay, so this brings us to the most important part of the entire process, what I'm calling the Great Decomposition. This is the moment where the ultimate fate of all that soil carbon gets decided. So you can think of decomposition as this giant control switch. As all that organic matter gets broken down, this one process determines everything. Does the carbon stay locked away safely in the soil, or does it get shot right back out into the atmosphere? And who's in charge of this giant switch? Well, meet the key players. It's this massive, completely invisible army of bacteria, fungi, and tons of other microorganisms. These guys are the planet's cleanup crew, its tireless recyclers. The way these microbes work is fascinating. They're essentially eating all this dead organic stuff to get energy. And just like us, when we breathe out, they release carbon dioxide as a waste product. This is called microbial respiration, and it's basically the main escape route for carbon to leave the soil and get back into the air. Now, don't let the chemical formulas scare you. All this is showing is exactly what we just talked about. The microbes take in organic matter, which is represented here by a simple sugar, and they take in oxygen. And what do they breathe out? Carbon dioxide and water. And for our climate story, that CO2 is the part that matters most. Right, but here's the thing. This whole decomposition process doesn't happen at the same speed everywhere. The local environment acts like a set of control knobs, and it can dial the speed of that CO2 release way up or way down. And this slide lays it out perfectly. In a place that's warm, wet, and has plenty of oxygen, like a tropical rainforest, those decomposers are on fire. They're super active, breaking stuff down really fast and sending carbon right back into the air. But in places that are cold and soggy, like peat bogs or the Arctic permafrost, the lack of warmth and oxygen slams the brakes on decomposition. So the dead stuff just piles up and up and up for millennia, creating these enormous vaults of stored carbon. For thousands and thousands of years, this whole system was more or less in balance. But now, human activities are starting to seriously tip the scales. We're cranking up the speed on those decomposition knobs. So how are we doing it? Well, here are 2 huge ways. When we clear forests, we expose the bare soil to the sun, which warms it up and kicks those microbes into a higher gear. And when we plow fields for farming, we're basically churning up the soil and injecting a bunch of oxygen deep down, which is like giving those decomposers a shot of adrenaline. They go into overdrive and release stored carbon way faster. But this next part is what's really terrifying. It isn't just about what we do directly to the land. The climate change we've already set in motion is creating its own dangerous feedback loop. As the whole planet gets warmer, those microbes in the soil are becoming more active everywhere, especially in those cold places that have been holding onto the most carbon. Let's just walk through this because it is so important. Global temperatures go up. That permanently frozen ground in the Arctic, the permafrost, starts to thaw out. This suddenly exposes tons of organic matter that's been locked in a deep freeze for thousands of years. The microbes wake up to an all-you-can-eat buffet and start releasing absolutely massive amounts of CO2. That extra CO2 in the atmosphere causes even more warming, which thaws more permafrost, and on it goes. The cycle feeds itself.
So what this all boils down to is that soil isn't just some passive storage box for carbon. No, it's a dynamic living system. It can be a carbon sink, taking in more carbon than it releases, or it can flip and become a carbon source, putting more out than it takes in. It all depends on this delicate balance, a balance that we are now pushing way off kilter.
And that leaves us with this one final, really critical question. For so long, the soil has been this silent partner, quietly helping us by locking away carbon. But as our world keeps warming, are we pushing it to a tipping point? Will the very ground beneath our feet turn from an ally into an adversary? Thank you for joining this explainer.